Number 1 wants us to find the displacement and the distance traveled by the particle during the given time interval, and they give us the velocity function in meters per second for the given particle. So definitely read through the box on displacement versus distance. Displacement is also called the net distance, and distance is sometimes called the total distance. Displacement, what that's going to do is area above the axis is going to be positive, area below the axis is negative, and then it adds those up. The integral does this by default, whereas distance, all of the area is considered positive. So in order to figure that out, we're going to actually have to break the interval or the integral up to where it's positive and where it's negative. So I'm going to mark, this is the positive area, and this is the negative area. And to find the displacement, again, we just need to integrate really the entire function on the interval, and it will automatically add these up and subtract these. So the displacement is not too hard. So I just want to integrate. So that's going to be equal to 6t to the fourth over 4 minus 6t cubed over 3 minus 12t squared over 2. And then I want to reduce that and also evaluate it. So that'll be 3 over 2 t to the fourth minus 2 t to the 3 minus 6t squared. And that's evaluated at 2 and negative 1. So that's going to be negative 16 minus a minus 2.5, which is going to be equal to negative 13.5 meters. So it is okay for the displacement to be negative. It just means that it's in the negative direction of the start point. So whatever that negative is being considered, whether it's down or left or whatever they choose to define it as, you can have negative displacement. So this was the integral by default. Whereas the distance, looks like I'm running out of room here. Let's go to the next slide. So the distance, to do this, we actually need to break up the interval, or the integral. I keep saying that. Break up the integral. And you want to do that where it crosses the axis. So at 0, that's really the cutoff point, because from negative 1 to 0, it's above the axis, and then from 0 to 2, it's below the axis. So I'm going to have two integrals, one from negative 1 to 0, and one from 0 to 2. So the same function, just two integrals. So the above is from negative 1 to 0, and it's my function. And then below, same function, just from 0 to 2. Okay, So then I want to evaluate these. And we've already evaluated the integral, so we know what it is. It's 3 over 2 to the fourth minus 2t cubed minus 6t squared. This is from negative 1 to 0. And then over here, same thing, just evaluated from 0 to 2. So this will be 0 minus a minus 2.5, which is 2.5. This will be negative 16 minus 0, which would be negative 16. And then you want to add the absolute values of these. So I'm not, there's no such thing as like a negative distance and a positive distance. I want to make everything positive. So if I take 2.5 plus 16, then I get 18.5 meters. So the particle traveled 18.5 meters total, but its displacement is that it ended up negative 13.5 meters in the negative direction of wherever it started.